Okay, so we've had a little bit of work on scale diagrams, and we're going to keep solving problems using scale factor. So in this lesson, we're going to be finding dimensions using scale factor. And remember, every time we are looking for scale factor, we're going to call that K. Okay, we're going to give that that concept the letter K. All right, and again, I always like to think of K as being new over original, right? And remember, if the new is smaller, K is going to be a fraction or a decimal less than 1. And if the new ends up being larger, then we're going to end up with a K factor that's greater than 1, right? An enlargement. So I find this one a lot easier to kind of work with than, you know, what the notes tell us. Or some the textbook also uses slightly different phrasing, and if you go online and look for support on this, I think you might find some different wording as well. Okay, so let's take a look at this question here. A pan in a child's dollhouse has a radius of 2 centimeters and a handle length of 3 centimeters. A comparable pan in a real life kitchen has a radius of 15 centimeters. So what's the scale factor? So the new thing, the new in this context is the toy, right? The kid's toy, and the original is the real life pan. So if we're going to set up K equals new over original, we have to find things that are comparable to each other, comparable side lengths. So the radius of the pan is 2 centimeters and the handle length is 3 centimeters. We're going to compare the radius of the real life pan in 15 centimeters. These are the only two numbers we need from this problem. We don't want to use that 3 centimeters because we don't know what the handle length of the real fry pan is. So scale factor K is new over original, and that's just going to be 2 centimeters over 15 centimeters. Our units cancel, and we end up with a scale factor of 2/15. You can put that in your calculator and turn that into a decimal if you'd like. You get a repeating decimal, so I just kind of find it a little bit tricky to work with. So we're just going to probably leave it at 2/15. The follow-up question is, what is the length of the real pan's handle? So we needed to determine the scale factor so that we can apply it now to that 3 centimeters. Okay, now we're going to use that 3 centimeters. And again, if we just kind of set up the structure of K equals new over original, we can substitute in the parts that we need. So K is 2/15. New is, well, the dollhouse handle of the pan is 3 centimeters, and what we don't know is this guy down here. All right, this is kind of that bad scenario where the unknown that we're looking for is in the denominator. So we've got a couple of things that we can do mathematically to try to make this work. One of the things we can do is we can just flip everything over. Okay, so what we can do is we can actually just write 15 over 2 equals x over 3. Okay, and I know that seems like a little bit like magic, but I promise you that mathematically it works just fine. And then we can use some cross multiplying. And this skill is going to be really helpful in our next unit when we do trig. Okay, so I want you to kind of see how whether we're working off of this guy or this guy, there's a really neat trick that we can do where the cross multiplying of two fractions kind of set up like this, where one is set up to be equal to the other. We can say that the product of these two guys, these cross guys, one on top and one on the bottom, is equal to the product of these guys here. Okay, and same thing here. 15 times 3 is the same as is equal to 2 times x. So if we set this up, we've got 2x, 2 times x equals 15 times 3. Okay, so that's what that cross multiplying does. Same thing down here. We've got, you know, if we did this 15 times 3 first, equals 2 times x. And I know that you guys realize that both of these are the same thing. Okay? So if we want to figure out what x is here, we just divide out that 2. We divide both sides by 2. So x equals 15 times 3 divided by 2. Okay? And this is a really, really important kind of math skill to be able to solve for a part of these equivalent ratios. Okay? And again, we're going to do this in our trig unit, so it's good if you get very comfortable with it. Okay, and sometimes, or eventually, you'll be able to just see that you can set this up to be 15 times 3 divided by 2 is what's left over here. Okay, put this in your calculator. 15 times 3 is 45, divided by 2 is 22.5 centimeters. Okay, and that's our final answer. Hopefully that makes sense. Kind of go through the math a couple times if you have to. Again, you don't need to do this part down here. It's just to kind of show you another equivalent way to write this. I usually don't like when the unknown is in the denominator of a fraction. So you can just kind of flip everything over so that it's no longer there. Okay, but turns out the math just takes us right to the answer anyway. Okay, and then please notice I have an answer with units. And I also want to check to make sure that my answer is reasonable. Is 22.5 centimeters a reasonable answer for the length of the handle of a pan? I think it's pretty reasonable, so I think we're on the right track here. Okay, let's take a look at one more problem, and then we'll get you to do some practice. So here is the dimensions of a what we want to do is we want to determine the dimensions of the actual vehicle. Okay, given that K is 0.05. All right, so what is 0.05? What does that mean? Does that mean that this new thing is a reduction or an enlargement? Okay, it means this is our new thing and it is a reduction compared to the original. Of course, that makes sense. This is definitely smaller than a real truck. So knowing that, let's figure out the dimensions. Let's figure out our widths. So we just get to use our very, very handy formula where K equals new over original. K in this case is 0.05. New, well, new is 9.2 because new is the car. The car needs to be smaller than, or sorry, the model needs to be smaller than the real car. Okay, so we're left with our length down here as our unknown. How do I get this guy by itself? Well, maybe you remember from some of our trig calculations last year where everything was always set up with fractions. We can just switch these two guys around, right? So that means that x equals 9.2 centimeters divided by 0.05, which is our scale factor. Scale factor does not have any units attached to it. Okay, when I put this in my calculator, I get 184 centimeters. 9.2 divided by 0.05 gives me 184 centimeters. That is a very reasonable width of a real truck, right? Of almost 2 meters. So that's probably that's a good answer. Okay, it's probably the right answer. It's very reasonable. Let's try the length. Okay, again, K equals new over original. 0.05 is K. New, the new length is 24.5, and the original length is is what we're looking for here. I'll call that L. L equals, switch these guys around, 24.5 divided by 0.05, and the original length is 490 centimeters, which is 4.9 meters, right? That is a very reasonable answer for the length of a car, of a truck. Okay, and then finally, height. If we use K equals new over original, whoops, 0.05 is 9 over x. X is 9 over 0.05. And when I do that, I get a height of 180 centimeters, which is 1.8 meters. Again, very reasonable. And the reason I'm talking about this kind of reasonableness is, what if you had switched these guys around? What if you mistook which one was the original and which one was new? Because you weren't thinking about the fact that this is supposed to be, or this is a number so much smaller than 1, and that our new this needs to create a reduction. Okay, so let's say you just kind of forgot about that, and you had this flipped around. You had these guys flipped around, okay, and you were solving, you know, 0.05 equals x over 9. When you did that, you'd be 0.45 centimeters. You would be finding that the height of the real truck is half a centimeter. That does not make sense. Okay, so that's why we're just stopping and thinking about all of our answers and whether or not those answers actually make sense in the real world. Okay, they should be very reasonable. All right, take care.